Okay. Good afternoon, everyone. On behalf of agricultureinformation.com, I like to invite the speaker, Mr. Deepak Dhruw, who will talk about agriculture, irrigation, and fertigation automation. And we begin. Thank you.
Yeah, hello everyone. Myself Deepak Dhruw from Bharat Aqua Solution, Raipur, Chhattisgarh. Actually, I am working in agriculture automation. Basically, my field is of irrigation and fertigation automation. Still, I am working from 2016. I am working in this automation projects, and we have developed our own automation and fertigation devices, plus that dosing machine, with the help of which a farmer can give a precise fertigation and irrigation to their plant. Now, before starting this automation, regarding this automation, once I inform you that as far as we have know that our India is a agriculture based cultural, so we are completely based on agriculture. Okay, so previously what is happening now? Basically, we are working with the old technologies, what we call it complete depending upon that manual operation. Okay, so everything was depending on the manual operation. First, we are starting with flood irrigation. Basically, our ancestors are working in irrigation. Like firstly, they are developing the flood irrigation. Then slowly we have developed, and from some international technologies, what we call it like drip irrigation. The drip irrigation introduced to our India, and most of the farmers are using the drip irrigation, basically, which are growing their fruits and vegetable. The fruits and vegetable farmers are basically working in their in drip irrigation. Okay, so in drip irrigation, what the advantage we are getting, that we are getting the advantage of irrigation plus fertigation we can do with this the help of drip irrigation. Okay, drip irrigation means like this type of tube we are using in the field, and this help us for what? For reducing our in a less water we can irrigate our plants. Okay, so this type of technology for their first step we have come to across of this. Now what is happening now? We uh, have technology has come, and have we adapted the technologies? Now what is happening? We are come across the automations also. In automation, what is happening? We are just targeting our field. Okay, so how much amount of water, how much amount of fertilizer we have to give in our field is done with this help of automations. Okay, in this agriculture automation, or we can call it like irrigation and fertigation automation. First, we automate our irrigation pumps plus our uh, valves. Okay, so both the irrigation pumps and valves we are using in automations. Okay, normal valve we are not using. We are going to use some automation automatic valves. So when we give a signal to that, it will on automatically. Okay, so have we come across this? We are using this sort of system. We are called it Smart F4. Have you shown in the picture? This is a system which is IoT based, which can be operated online and offline both. We are having app also, mobile app also. A farmer can easily interact with the app, and with the help of mobile application, he can target his field for how much in each what time we have to irrigate the field and how much we have to irrigate the field. In both can be done with this the system. Okay, so here we are moving from one step ahead also. One step ahead means not even we are giving irrigation, we are doing fertigation also. And for this we can later also we can discuss for that one. First we will start our presentation regarding this automation. So this is our this is our dosing machine, or we call it like a fertigation machine, in where we can control both irrigation plus fertigation also. Okay, so here you can see a right side one controller is there, which can commands the valve in the field to on and off, plus that dosing pump also. What is the use of that fertigation system is to that reduce water usage and wastage, and reduce the wastage of fertilizer. Manually, what is happening? In manually, what are they doing now? Suppose our field required only in 1 acre of field we are required only 8,000 liter of water. Okay, or we have to irrigate 15 minutes only, but manually it is not possible because what is happening now in the labor are not conscious about that one. So what they will do, they will irrigate over to the plant. It will also affect our plant. Uh, it will affect our plants and also our yield also. The plant we are reaching the crop now, their yield also will be affected due to over irrigation. Over irrigation also will affect that crop yield, plus less irrigation also it will affect the crop yield. So precisely we have to give the water and the fertilizer to the plant. If we give a proper and this is we call it precision farming. Even when we giving a proper fertilizer to the plant also, there is a proper measurement. Plant is like a small baby for us. What is the thing is a small baby means, like time to time a small baby body we have to take care of the take how do we have to take care of the baby, like a particular we have to give a small in time to time we have to feed to the small baby, like that also in a plant also the same thing happening, like time to time we have to irrigate to the field. The challenges basically we're facing in the field now is that water security. Like some of the time in the summer season, we have less water than, but then also at the time of that, we have to irrigate to the field. So without in manual process, for not possible at that time. And the second is that in the manual is happening. What is happening now? The excess irrigation we are doing. Okay. So that also we have to reduce the automation, because automation when we have set something, some of the amount of the water or in the fertilizer, it will go that much only. Then increase in labor costs. Actually, in a big field, like if you are having 50 acre, 100 acres, it's not possible with the help of manual irrigation to irrigate in the daytime, because in the day, in a in that time now, in the labor only is having 7 to 8 hour only. It's not much more that. And even in the big field, we have to irrigate at night time also. The flagship of our irrigation system is that we can use in the both in a medium scale and large scale farmer. It is very easily programmable, and we can manage the nutritions also. We can precisely give the water management also to the plant. This is the features we are getting from this our automation system. This is a block diagram. This is the basic small block diagram of our system. You can see here one pond is there in the left side of that diagram. Then one filter is there. Then after the filter, we are using this type of electronic valve to irrigate our field. Our rolling machine, what is happening now? We are having the different channels. With this loading channel we have introducing, we are having some tanks over there. In basically in the tanks we are putting some npk solution. In that npk solution where it is used to inject, we can giving the target to the plant how much npk is required to the plant. According to that we can set in the system, and according to that irrigation or fertigation we can do with this fertigation system. Second is that it is a GUI based programmable. We can easily with the help of GUI we can having the user can easily program his schedule, and that quantity. And if you call in the irrigation method now, we are having three type of basically irrigation method we are having. First is time based, second is quantity based, and third is sensor based. Time based means how right now what the farmer are doing. Suppose if they are in manual process now, what they are doing, they're putting their pump on for 30 minutes, and after 30 minutes they will turn off the pump. Okay, so they are having only single method. In the manual method for giving the water is only the time based, but in automation we are having three type of method. First is time, second is quantity, third is sensor based. Time based means suppose we want to give a 30 minutes of program, then we will in our GUI we can target to that particular valve of 30 minutes, and it will irrigate that one and fertigate that one. Second is quantity based. Quantity based means how much evaporation will be there in a required in the field. According to that we can give a irrigation to the plant. Suppose 1 mm of 1 mm of evaporation is there, na? And what we will do, we will give an acre like a 4,000 liter of water. Okay. In summer, what is happening? In summer season, most of the area, the farmer used to have to irrigate up to 8 mm. 8 mm means 8 into 4,000. That much of water is required for per acre of land. And it will also depending upon the canopy of the plant. Suppose if we are growing a chili, then its canopy is small, then evaporation factor we will take it less. Then if we are taking a banana, then evaporation ratio will be large. Then according to that, we have to select how much mm of water we have to provide to the plant according to the size of the canopy. Third is sensor based. Sensor based means like we are using a moisture sensor in a plant. Suppose we are targeting and the moisture sensor means how much centibar water we have to give to the plant. Okay. Here, when the according to that also we can irrigate to the plant. When the field getting dry, automatically the system get that command that signal that the field is getting dry, and he will start a fertigation and irrigation. Once it reach the target level, automatically it will stop that schedule. Then in uh, in automation, basically we are concentration about that the fertilizer intake by take up by the plant, and that is most important when we balancing the EC and pH of that fertigation or irrigation water. So with the help of dosing channel, we are giving to the target that how to control the EC and pH of that water. This is the most important topic in automation regarding the EC and pH. Later on slide is there. I will explain how we can go into how we are using the EC and pH. Then automation getting the logs also, then applications also, the alarms also. Alarm means with the help of automation, farmer is manual, he can't able to know, he didn't able to know that is there any water leakage is there or any filter choke is there. He can't able to get that notification. But in automation, we are providing some of type that low flow alarm, high flow alarm, and no flow alarm. So suppose the pumps are not started, automatically the in a notification, the farmer or a client should receive the notification there is no flow. If there is any water leakage is there, then automatically the system will alert for the high flow. If there is if certain amount of water, suppose in a drip irrigation, uh, um, the filter is jam or filter is choked, then flow will be not constant. So at that time, the low flow alarm will be active. The automation features we can understand so small here that cloud based we are getting this all the systems, all the data will be in the cloud, and easily we can access with our mobile. Remotely we can access our system anywhere in the world. This is a small UI of our system where you can identify how we are using this UI. This is a left side in the first page of our UI. Here you can understand that how the pumps are started. You know about the dosings, and here one EC and pH is there. How much EC is running for that particular fertilizer. Here pH it is showing 7. So this all we are getting all the things in our mobile app, and this is our water meter. In it cubic meter it is showing that 36,000 meter cubic water is drawing from that uh, particular wall. Here the walls are there. Green means 16 number wall is on. So this by this simple UI, a farmer can easily understand what is going on in his field. He can easily program all the things. This is sensors. Basically, for the automation, this is a major important sensor we are using in the field. First is pH sensor. pH sensor is to know what type, at what pH we are irrigating our field, or what pH we are irrigating our we are giving fertigation to the plant. And there is tank level sensor also. Then tank level sensor means when we are having some underground tank, some tank we are call it what level how much it is filled, we are using tank level sensor. Pressure sensor is there because in the drip irrigation we required 1 kg of pressure that at the end of the lateral. So pressure sensor is also important for the automation. If we are using in a less pressure in the drip irrigation, that drip pipe get being choked or not the properly, no, we are not getting the even even crop in the field also. The last is soil moisture sensor. With the help of soil moisture sensor, we can know how much moisture we are getting in our field. Due to with the help of moisture sensor, uh, we can irrigate our field or fertigation our field. These are some of that installation we have done in the field. This is some of the example. Here we are using our system, and in the drums we are putting an NPK solution. Uh, Basically, with the help of automation, we can manage how to use the water and the fertilizer. As per day by day, the water availability in the summer, basically in summer is getting very less. In the most of the area, it's getting dry also. So how to manage that water is only possible with our fertigation system, what we can call it the automation system. And fertigations mean how this drum we are using these drums to provide that NPK solution in the drum. Is what is happening now. How much the plant, how much required that fertilizer, we can that much only fertilizer we are giving to the plant, not excess to the plant, not lesser to the plant. We can directly manage now how much according to the age of the plant, how much fertilizer is required. That much fertilizer only we can give to the plant. That will reduce our fertilizer cost also. There is no depending upon the manpower and no human error also. There is no human error also. There is no manpower means in 24/7 we can use the system. Even the night also we can provide a irrigation fertigation of the plant. When there is no conservation electricity means we are not suppose we require only a 1 hour of irrigation, so we provide only 1 hour of irrigation, not more than 1 hour of irrigation. So we can save electricity also. We can conserve the electricity also. Online access, we can access the system via mobile. We are having internet facility in all over India. So easily we can access our system anywhere we are in our country or else in our world. Notification alert we will get if there any water leakage is there or any filter choke will be coming like such type of error coming in the field, we get a notification on our systems. Basically, we are using automation in three categories. First is open field. Most of the automation we are using in open field for vegetables and fertilizer. Then greenhouse, where we are greenhouse also, and for nursery also we are using this automation. Then corporate farmers are also using the automation for the corporate field, the big fields to manage for their irrigation fertigation. We are using such type of automation in the fields. Previously also we are discussing about that automation. In our automation, the major we are calling as to operate our pumps and valves. But here one more important thing is there that is to maintain that EC and pH. EC and pH of the fertilizer water. What is happening now? We are having that two sensor, that EC sensor and pH sensor, and in our automation we are giving a target of like 6.5. We are giving a target of 6.5 to that system, because in the 6.5 what is happening now, here you can check here in the 6.5 what we are getting, that all the nutrition like nitrogen, phosphorus, potassium, sulfur, calcium, all we are getting in the 6.5. So we are in our system we have a property that we can target our system to maintain that the water pH in the 6.5. Okay, so by maintaining the 6.5, what is happening? The plant will easily intake all the fertilizer which we are giving to the plant. When we are irrigating or fertigation to the plant, we are managing that of soil, water pH to 6.5. And EC also we are also managing. How we are managing? Suppose according to plant age or plant type, every plant type having a certain property that like 2 EC. EC we call it electrical conductivity. Suppose we are not maintaining that the EC level of the plant. Suppose fertilizer. What is fertilizer? Fertilizer is nothing but like a salt. When we dissolve the salt in a water, then the EC electrical conductivity will increase. Suppose half of half tablespoon salt I mix in a glass of water and I will drink, then I can able to drink. But if we pour 4 tablespoon of water in a glass and then I can and I try to drink that water, it is not possible for me because it's too salty for me. So I can't accept that water. Same thing with the plant also. What is happening when we give higher EC or the fertilizer to the plant, then the feeding root will not accepting that fertilizer. After that, what will happen? That fertilizer will be remain in the field and it will pollute the field also, and it will damage the root zone of the plant also. So once we are going with automation, we have to check for both that for proper we have to maintain the proper pH of the water and proper EC when we are giving a fertilizer to the plant. Basically, the in vegetables we are not going maximum to the 2 EC. 2 EC for vegetable is maximum. So in automation, we are giving a target of 2 EC. When when the EC is increasing, automated system will reduce that EC and maintain to 2 EC only. Less EC will be good for the plant, but maximum that higher side of the EC will damage the plant roots. So we have to check both the thing for better yield, for better crop health. We have to check for the AC and pH. So our system we are using for distributed dosing channel to maintain that both the AC and pH of the plant very well. So by the using of this automation, by proper fertigation and irrigation and balancing that AC and pH, that our crop yield and crop production will be increased from 20 to 25%. The farmer are getting the profit in their field by using the automations. And the secondary thing is that we are not using any thumb rule for this one. How much plant according to the plant's age, we the dosing will be defined to the plant. How much dosing it should be given to the plant. According to that only we are giving to the plants, and for that we are getting the result in the field also. So basically, the automations are in categorized in the we can call it in the three manners. First is for operating that valves and pumps, and the second is for fertigation, and third for this sort of sensor which are used for maintaining the AC and pH. In automation, we are having different types of method for operating the valves and pumps. Suppose we are using wire and wireless valve also. Here I'm not mentioning in this PPT, but we are using in our field both wire and wireless wall. I will in wireless wall, what is happening? Basically, we are using that wireless wall. So mm, if we are having a big field around in a 1 kilometer radius, okay. So at that time, what we have to do, we are not using any wire operation in the field. We are using wireless. So we are putting in the field a wireless wall to operate our field walls, and we are having some devices also to operate that pumps also in a wireless manner. So in automation, is a very big field in the field of agriculture. Still we are come to this much of automation regarding the irrigation and fertigation, and now our farmers and our clients are using this automation device, and which is helping them for taking the much more yield by using their less effort, and less effort plus the cost of the cost of the farming also get reduced. Well, first we are reducing that water, and second we are properly we are using a fertilizer. So by this all this method we can properly irrigation and fertigation to our plant. Now in India, different type of variety we are using. Uh, like basically we all know in a previously we are only used to have paddy crop, Now all the types of crops we can growing in India, in all the segments, in all the states we are having different crops. Even the foreign crops also we are adapting right now, like blueberry and avocado also is are we are growing in our India. For this type of crop, all the farmers are used to having, they are going to adapt all this type of automation for their for the better yield and better for the better plant. So thank you, and this is what I have to say. This
Hello.
hello.
Yeah, Mr. Deepak. So, is it possible for you to on your video if you are
Yeah, yeah.
comfortable with it?
Yeah.
Yes. Okay. So, thank you for the detailed presentation. So, I'll now take up some questions.
Yeah. Okay.
Yeah. So, what are the key benefits of automating irrigation and fertigation systems for small and marginal farmers?
Small and marginal farmers are very important for that automation. It's basically right now what is happening now. Due to busy schedule, farmers are not attentive in their field. Okay, so with the help of the automation, he can properly use his fertilizer and plus water also. With the help of automation, what the thing is, he can program or he can target that his field, how much irrigation or how much fertilizer he has to provide uh, uh, to the field, and he can easily irrigate and fertigate without any human interference over there. So properly he can use all his water and also fertilizer properly. He can irrigate to the field, and plus advantage what he is giving that he can reduce his fertilizer cost over there.
Okay. And how does fertigation automation improve fertilizer use efficiency compared to traditional methods?
In traditional method, madam, they don't know how to properly irrigate or fertigate, and the most important thing that EC and pH. In traditional method, what is happening now? They will soluble this. They will mix their fertilizer in the tank, and they are providing the field. Okay, so don't know how the EC is there and what are the pH is there. If the EC and pH is higher side, the plant will not take up their fertilizer. It will be rested on the field over there. So in the later on, what is happening? The soil will pollute, and this will happen. If you manage the EC and pH, whatever the fertilizer we are giving to the plant, it totally kept take up by that crops. And even with the help of drip irrigation, we can call it that in any of the soil is there, any of the soil is there, we can easily we can crop over there. We don't require a particular soil over there. So with the help of automation we can increase our yield, and we can don't bother about the area also. What the soil is there, we can easily grow a crop over there.
Okay. And what types of sensors or technologies are commonly used in automated irrigation systems?
Basically, technology we're using that for pump automation, valve automation, then filter flushing option is coming. Then then dosing is there. Dosing is the most important right now, because without any dosing machine, the farmer can't able to irrigate. Like dosing machine means how we are taking our lunch, na? Like we are having a rice, curd, and all the things at the same plate. Like that, also the dosing machine also provide the same thing to the plant. With that machine, we can provide NPK solution at the same time to the plant. So this will help the plant to grow very well, and it will at the harvest time we will get more fruits over there also.
Okay. And how does fertigation controller work, and can it be integrated with existing drip or sprinkler systems?
Yeah, we have integrated. We have our controllers also. With the help of controllers, we can giving to that. We are having interference with the help of relays. We can on our dosing pumps, irrigation pumps, and valves also. With special types of valves are coming. Electrical valve we are calling it. With electrical valve, we can just turn on the valve pumps, and we can start our fertigation. In
Okay.
We are having a mobile app also. With the help of mobile app, we can anywhere from the world we can access our field.
Okay. And what is the role of IoT and mobile apps in managing irrigation and fertigation?
Ma'am, I told you that now the farmer what they are doing, they're having multiple field. Okay, once you are they're having one field or two field, and most of the time they are not. They are having some other works also. Okay, so with the help of mobile app, or we can call it IoT, what is happening now? Suppose tomorrow what I have to give to the field, today I can set, or next for 10 days what I have to make a give the schedule to the plant now, we can schedule today only. Today I will set for the next 10 days, and I will be free from the field. The irrigation will and fertigation will be automatically going to the getting the plants.
Okay. And can the system be customized based on crop type and soil conditions?
Basically, we are we are having to and inline system. This two type of system we are having. Images which I show in the PPT is of bypass system, which are basically used in open field, and inline system we are using in our this polyhouses. Because in polyhouses, or we can call it like our hydroponics, the pH and EC we have to check very frequently. So we are having two type of system. And
Okay.
customization means basically the farmer, basically traditional method they are used to irrigate their field in a time based. Have we introduced our automation? Now they can irrigate in a time based also, and if they want, they can use in a quantity also.
Okay. And um, how, sorry, what is the approximate cost of installing a basic automated irrigation and fertigation system for 1 acre?
Basically, ma'am, for the it will not like acres actually. According to the usage, they have to we can giving the cost the farmer. But basically, a small it will be starting from the 1 lakh, and from starting from 1 lakh as per their requirement. If they want sensor, like they want EC sensor, then PS sensor, then moisture sensor, that it will increase the cost of that. Automation, and it will goes up to 10 lakh also. From 1 to 10 lakh we are having that customization option in our system.
Okay. And are there any
The
government?
basic is that only valve and pump automation, then fertigation, then the sensor based. The three categories we are having.
Okay. And are there any government subsidies or schemes available to support farmers
Still,
adopting this?
this is basically we are calling this is luxury based project, or high tech like projects we can call it. Like. So right now there is no subsidy in automation.
Okay. And can the system be customized based on crop type and soil conditions?
Yeah. There is the option to customize uh, according to the crop and medium based. According to that we can customize.
Okay. And how suitable is automation for horticulture crops versus field crops?
Basically, in horticulture, 100% we can use the systems. In paddy, it's not possible, but paddy most of the farmers are using. But in the result oriented, we can take it like in the horticulture, because in horticulture we are growing that vegetable and fruits. So in that part we are using drip also. So in that one we can use automations. We have to use automation. Automation we have to use in this horticultures.
Okay. And what are the maintenance need of these automated systems?
We have to just check that our voltage supply is okay, because automation is working on the that AC supply. So most important thing is that our supply is okay, then there is no maintenance cost will be there.
Okay. And what challenges do farmers commonly face while adopting or using irrigation or fertigation automation?
Actually, now traditionally they are using their old method now. So the old the young generation farmer, they are going to adapt easily. They are understanding the advantage of the automation. They are adapting. But the farmer, they are using their old traditional method now. They are not adapting at automation. They are thinking that how we are going to operate the system. It will be difficult to operate like that. They are thinking. But the new generation is they know how they can easily once the farmer which is capable to handle his mobile, he can handle his automations also. And second thing
Okay.
is cost also, because there is no subsidy provided by the government in that automation. Then sometimes the cost also is coming a barrier for the farmer to adapt the automation.
Okay. And have you seen a noticeable increase in yield or water savings among farmers using
Yeah,
your
yeah,
systems?
yeah, yeah, 100%. The once we installation this automation in the field now, farmer are saying that we are getting the result. The quality of the fruits getting increased, then the quantity also increase, and the most thing is that they are saying that enough less fertilizer and a proper use of water they are using right now. Previously, they are not capable to handle this wastage of water and wastage of fertilizer. With the help of automation, they know how to how water they require in the field and how much fertilizer they require in the field. So according to that, they are getting their advantage for that one also. And even the production in just for properly timing, in a properly timing when we irrigate the field, that crop yield also increasing to 20-25%.
Okay. So last question. How
Yeah.
can this technology contribute to climate smart agriculture or sustainable farming practices?
Sorry, pardon.
Wait, I'll just repeat. How can this technology contribute to climate smart agriculture or sustainable farming practices?
Basically, for the irrigation and the fertigation, what is happening now? The farmers know at what climate, at what condition, how they are going to irrigate their plant. Easily, they are changing their schedule according to their usage and requirement.
Okay. Okay. One second. Okay, Mr. Deepak, I don't see any more questions. So now we
Yeah.
have come to end of question round. On behalf of agricultureinformation.com, we like to thank you for the detailed presentation and answering all the questions. So we'll be ending this meeting now.
Okay. Thank you.
Thank you. Bye-bye.